Hi, you are welcome to the continuation of our video training series on inventory management and control. This is our module 3 of 15. The title of this module is Inventory Control Techniques. In this module, we are going to look at all the techniques that could be applied to achieve optimal level of inventory. Inventory control is defined by CIMA. CIMA is the Chartered Institute of Management Accountants. They define inventory control as a function of ensuring that sufficient inventory is retained in stock to meet all requirements without carrying unnecessarily large stocks. In this model, we are going to look at all the necessary inventory control methods that we can apply at our different companies to achieve optimal cost of inventory. These are the different inventory control methods. They are setting inventory levels. So by setting inventory levels, we'll use concepts such as EOQ, economic order quantity, maximum level, reorder level, minimum level, buffer level. All that are what we can apply under setting inventory levels. Classification of inventory. We use concepts just such as ABC analysis, FSN analysis, VED analysis, etc. Then we'll look at setting physical control of inventory, where we'll apply stockroom control techniques, documentations, handling equipment, ROFID, UPC. We'll apply all that under physical control. Then we'll use ratio analysis to measure the performance of inventory in our organization. All these are things we are going to look from now onwards. For this particular model, we are going to look at setting inventory levels, where we'll consider EOQ, maximum level, etc. Okay, let's go. How much to order? If we are managing inventory, how much to order and when to order is the core question that we must answer at all times. We must answer this question: how much do we need to order and when do we need to order? This module, we shall get the answer to this question. Then in answering this question, we need to understand the background. The background is in what we call inventory management models. And that model is about dependent demand model and independent demand model. Let's look at a model. Is a representation of the construction and working of a system of interest. That's what a model is. It represents the construction of a working system. So we use that model to interpret real life situation. So we are going to look at dependent and independent model. This model attempts to explain the demand with certainty and demand we are not sure it will come. There are two types of demand. One type of demand is the one that we know is for certain, and the other one is the one that we are not sure. We are forecasting, we are estimating that it will come. So let's go. Dependent demand is the demand that we are sure it will come. So our plan for this demand is more concrete. So we use actual numbers to calculate the demand quantity. For example, A bicycle manufacturer who plans to produce 100 bicycles next year, we plan to order 200 units of bicycle tires. Bicycle tires in this sense is a dependent demand, because you have already estimated, you had planned your production. So all that you're going to do now, you are sure of what you are going to do to satisfy the plan that you have. The quantity of tires is known because we know the production plan provides for 100 bicycles, and each bicycle carries 2 tires. Independent demand is the demand that we don't know for certain that customers will buy. Here we use forecasting and probability to work out the plan. This model we shall treat dependent demand and therefore use concepts such as EOQ, maximum level, reorder level, etc. EOQ, or economic order quantity. To have a solid background in understanding what EOQ is, we need to first understand the relationship between ordering cost and carrying cost. You can see from this diagram that carrying cost is coming down. Ordering cost is coming down while carrying cost is going up. So that is the relationship. Carrying cost is going up, ordering cost is coming down. We would like to use a table to explain this relationship. This is our explanation. Assuming that we have a demand of 4,000 units of an item, let's say bicycle tires, in a year, and the annual carrying cost, we said before that carrying cost is a per unit cost. Annual carrying cost is 5 naira per annum, and the annual ordering cost is 100 naira per order. So this table, let's follow this table and understand the explanation of the relationship between carrying cost and ordering cost. Then after that, we go back to EOQ. This is number of orders. This is order quantity. This is total ordering cost, which is 100 naira. This is total carrying cost, which is 5 naira. This is total cost of inventory. So let's follow it. If we have 4,000 units as our demand for the whole year, in the first condition, we are ordering this 4,000 at once. The whole 4,000, we say, supplier, give us 4,000 units of bicycle tires. We are going to pay ordering cost. That ordering cost is 100 naira. If we multiply that 100 naira by the number of times we are making that order, which is 1, we'll get 100 naira as being ordering cost we are going to pay. Then the total carrying cost, which means we are going to store all these 4,000 in our warehouse. The formula for carrying cost is the annual demand divided by 2 multiplied by the carrying cost per unit. So if we do that, we are going to get 10,000 naira, where ordering cost is 100 naira, carrying cost is 10,000 naira. Okay, then the second option is that we choose to buy or order 400, which means each time we will order 400 units. It means for us to order all the 4,000 units that we have in a year, we are going to make 10 orders. If each order is 100 naira, we multiply that 100 naira by 10, we are going to get 1,000 naira. Okay, then let's look at what carrying cost is going to be. Carrying cost is the quantity that we order divided by 2 multiplied by 5 naira, which is the carrying cost. We are going to get 1,000 naira. Okay, if we take another option, 20 we make 20 orders of 200 units each time, we are going to get 100 multiplied by 20, which will give us ordering cost of 2,000 and carrying cost of 500. So if we observe what is happening here is that the first condition where we had to spend only 100 naira as ordering cost, we are spending 10,000 naira as carrying cost. Then the second condition, we increase the ordering cost because we increase the number of orders to 1,000. Then carrying cost comes to exactly 1,000. Okay, so if we go down to making 20 orders, our ordering cost will be 2,000 and our carrying cost will be 500. So if you observe, you discover that the two costs behave in a way that when one is up, the other one is down. When the other one is down, the other one is up. There is only one condition where the two costs, the carrying cost and the ordering cost, becomes equal, and that is when we make 10 orders in a year and we buy 400 units each time, and that is when the ordering cost is 1,000 and the carrying cost is 1,000. That is the position where we are looking at. That is where we call the economic order quantity, the EOQ, where the two costs meet at the same point. We shall get more explanation of this concept as we progress. So this picture shows exactly the behavior of the economic order quantity. Economic order quantity attempts to balance the two costs and says that the point where these two costs, ordering costs and carrying costs, are equal is the point where the total cost of inventory is minimum. That is the point that if you are managing inventory, that is the point that you will continue to ensure that each time you order a unit, that the cost of carrying, the cost of maintaining inventory and the cost of ordering inventory will be equal. That is the principle, the concept of economic order quantity. We shall still go ahead to use other examples to explain what this principle is. The economic order quantity is the order quantity that minimizes the total carrying costs and the total ordering costs in inventory management. We can get that quantity when the ordering cost is equal to the carrying cost. This model was developed by Ford Whiteman Harris in 1913. This is the formula that is used to derive that quantity. If you use this formula, you will get the quantity that when you buy or you order, the total carrying cost and the total ordering cost will be equal, and that is the point where you will get the minimum cost of investment in inventory. And this formula is EOQ, which is economic order quantity, is equal to the square root of 2 times D times S all over H, where D is equal to annual demand, S is equal to ordering cost per order, and H is equal to annual carrying costs. This EOQ has some assumptions. These are the basic conditions that this EOQ will work. And these conditions are: 1, that annual demand is known and constant. That is to say that what you are going to use next year, the total demand next year, you know it, and it is constant, which means it's not going to change, which means all your plans on that demand will work. Then another assumption is that ordering cost per order is known and it is constant, which means it will not change. It is with certainty it will not change. Then the third condition is that carrying cost per unit is known and it is constant. Then the fourth condition is that lead time is the time between placing an order and when you receive the supply, is 0. This is called instantaneous replenishment, which means when the materials you're using or the goods in your warehouse that you're using finishes, as soon as you finish the last material or the last product, you instantaneously receive another supply, which means there is no gap between supply and when you order. So these are the necessary assumptions of economic order quantity, and it is expected that these conditions are things that will happen before this formula will work. But there are some criticisms of these assumptions based on basic realities in day-to-day life in our society. So these criticisms are like this. First one, let us look at the first assumption. The first assumption says the annual demand is known and constant. The criticisms of that is that the taste and preferences, these are the things that affect demand. The taste of people and preference of people. The taste of people can change. Somebody can tell you that Bonvita is the best product in the market, but you were using Milo before, and you went to buy Bonvita. The first day you use Bonvita, you say, so this is so beautiful. You will not buy that Milo again because your taste have changed. That affects the quantity of Bonvita that is demanded in the market. Again, the income that people take is also a measure. It also affects demand. If income increases, people tend to buy more. If income reduces, people tend to buy less. So that affects demand also. The prices of related goods, which is competition in the market. If your own goods, the price is high, and related goods, which are complementary goods, the prices are low, demand for your goods will be less. So you may not have the knowledge and the certainty that the demand is going to be known next year and is going to be constant. The number of consumers in a market can also affect the demand for a particular goods. If there is more people that are asking for the goods, the demand will increase. If there is less number of persons, demand will reduce. So those are the things that affect demand. Advertisement can also alter the demand of a particular good in a year. So you may not be certain that the quantity that you have planned to produce is you are going to produce them, and that is what people will buy. Then another thing that affects, another assumption is that ordering cost per order is known and it is constant. There is no society that the prices of goods are the same from January to December. So ordering costs may change during the year due to inflation, competition, etc. These are things that can change the prices of goods. So we cannot know for certain that the prices will be the same and it is constant. Then carrying costs per unit may also not be constant. It may also change. Then finally, the fourth assumption is that lead time, which is the time between placing an order and receiving that order, is zero. Lead time may not be zero in real life situation as a result of supplier failure. Supplier may fail due to strike in his company or what we call acts of God. Acts of God is when we have earthquake, when we have flood, when there are things that we cannot control at all. It is called act of God. This can happen and people may not be able to supply. There could be war like it is in Ukraine. We hear of so many millions of tons of grains that are held up in Ukraine because of war. So the companies that these grains were to be supplied to can never have them because there is no enabling environment for them to supply. So there is no time in life that lead time can be instantaneous. It's not possible. So these are the criticisms of the assumption of the EOQ. The EOQ formula, as we explained earlier, is derived by using this mathematical derivation. If you see here, we say total cost is equal to carrying cost. This Q over 2 multiplied by H is carrying cost plus ordering cost, which is annual demand over quantity multiplied by S. That is the formula for total cost of inventory. But at EOQ, what we are discussing now is EOQ, economic order quantity. At EOQ, the ordering cost is equal, the carrying cost is equal to the ordering cost. So if we write like that, at EOQ, quantity divided by 2 multiplied by H equals to D over Q multiplied by S. That is the statement of fact. If we cross multiply this equation, we will get Q squared multiplied by H equals to 2D multiplied by S. If we divide both sides by H, we will get Q squared is equal to 2DS divided by H. If we square both sides of the equation, we will get Q equals to the square root of 2DS over H. That is the quantity we are looking for in our explanation before. That is the 400 units. So if we apply 400 units, if we apply quantity equals to 2DS, that is 2 multiplied by annual demand, which is 4,000, multiplied by S, which is ordering cost, divided by carrying cost, we will get 4,000 units. So this formula is what we call the economic order quantity, and this is how it was derived from the beginning. This formula is called the supermodel because even when those assumptions we were discussing before tend to portray the fact that they cannot work, they are not possible to work like that, we still discover that each time we apply the economic order quantity formula, we get the results that we require without those conditions being fulfilled. So it is called a super model. Let us look at an example of that we explain all the conditions about economic order quantity. Problem number 1. A local distributor for a tire manufacturing company expects to sell approximately 4,000 units of tire of certain size and tread design next year. Annual carrying cost is 5 naira per tire and ordering cost is 100 naira per order. The distributor works 288 days in a year. Calculate the economic order quantity. 2. How many times per year does the firm reorder inventory? 3. What is the total carrying cost for the year? 4. What is the total ordering cost for the year? 5. What is the order cycle? Order cycle is the time between each order that you make. That if you order today, how many days will it pass before you order again? That's what we call order cycle. So this question carries all the things that we need to know about economic order quantity. If we need to know the quantity, we need to know how many times we need to order, we need to know the carrying cost, we need to know the ordering cost, we need to know the time in between different orders. So let's go to look at the solution to this problem. This is the solution to the problem. We have said that economic order quantity is equal to the square root of 2ds over h. If we expand that, we will get 2 multiplied by 4,000, which is the annual demand that we are talking of, multiplied by 100, which is the ordering cost, divided by 5, which is the carrying cost. If we expand this, we will get 400 units. So 400 units, just like we outlined in the table that we discussed earlier, 400 units is the number of tires that if we buy, the total carrying cost will be 1,000 and the total ordering cost will be 1,000. That is the unit that we need to buy. So let's look at the solution to the second question, which is the number of orders. If we are looking for a number of orders, it's simple. If somebody says, how many times are you going to order goods in a year, that you know the fixed number of the goods and you know the fixed number that you order each time, we know that the total number of tires that will be required to be produced in a year is 4,000, and we know that each time we are going to buy 400. It's simple to divide the 4,000 by 400 and we'll get 10 orders. Then the third question is the total carrying cost for the year. Carrying cost is equal to the quantity divided by 2 multiplied by h, which is the carrying cost per unit. And that is the quantity that we're going to buy each time is going to be 400 divided by 2 multiplied by 5. We'll get 1,000. The total ordering cost for the year is equal to D over Q multiplied by S equals to 4,000 divided by 400 multiplied by 100, which is also 1,000. This further confirms that this 400 unit is the economic order quantity, because at this unit we have the ordering cost to be 1,000 and the carrying cost to be 1,000. Then the final solution to the final problem is that we need to find the order cycle. Order cycle means the quantity of the goods that we are going to buy each time, which is 400 units, divided by the total annual demand multiplied by the annual work days. These annual work days could be 365 days. but here we are looking at only the working days. So if you divide 400 by 4,000 multiplied by 288, which is number of working days in a year, we have 28.8 days, which is just about 4 weeks. So this is how to work out problems involving economic order quantity. This explains all that you need to know about EOQ. Then this is taking an Microsoft Excel explanation of what we have discussed so far. We can still use Excel to derive that. So if you look at options, place option just as it is in this slide, then the other size as it is in this slide, you will get, if you plot it on the graph, you will get a graph that will look like this. So here the blue curve represents the total cost of inventory. Then the red straight line represents the carrying cost of inventory. Then the yellow one represents the ordering cost. So if you look at the point that these two costs, that is the ordering cost and the carrying cost, meet, that is the point that if you draw a line down, if you drop a line down from here, you will discover that that is 400, because next to that is 500. If you drop that line down, it's 400. If you drop this line from here, is 1000. It's 1000. So that is the calculation we did by a mathematical calculation that time. If you plot a graph in Excel, you will still get the same result. Then if you look at the total cost, they say the point where the total cost is at minimum. If you draw a line from this 2000 down, you will meet the point where the total cost is at minimum. If you draw a line down, you will get to the point where the total number of units will be 400. So that is the Microsoft Excel explanation of the economic order quantity. We can also support you in doing this if you contact us at forpressprocurement@gmail.com. Hi, this is awesome. This is the end of this module. In this module, we've gotten an insight into methods of inventory control, and we will also look at the EOQ with discount. This EOQ that we looked in this module is ordinarily the basic form of EOQ. Now we are going to look at the EOQ that will apply discount on the price and see the difference in how it is going to look like. Until then, why not join us? It's going to be another wonderful experience ahead. Thank you for your time. My name is Anderson Dumle Nagbe. You can reach me at forpressprocurement@gmail.com.